All right, we're going to make a start. So I'm Phil Wilcock, and this is my
Hold on, let me
colleague.
see if the recording is the recording man on. This recording's going. You can start now.
Can I?
Yeah.
Thank you very much. So I'm Phil. This is Andreas. We run a small company called 2 Pint Software, and we build solutions around content delivery, caching, sharing, that kind of thing. Branch cache, bits, config manager. So the reason that we put this little talk together is that we are developing a cloud-based service to extend what we do on premises to the cloud, because we'll explain as we go along. But we always like to get a little bit of an idea of the audience and what you want to get out of the session. So any Office 365 users or deployers? Okay,
Five, six,
yeah.
seven, 8, 9. Yeah.
Well, today as an example, we're looking at Office 365 and how you can improve the delivery of that service using branch cache and other technologies, but you can apply it to any cloud service, really. So it's all about optimizing what you do.
Who's the technical? Yesterday we have a talk, and I think we went a little bit too technical.
A little bit.
Who's the technical audience in here?
I think everyone's fairly technical.
Fairly technical. All right, good. We'll
Oh.
try not to go too deep today, then.
A lot of this is fairly well, the concept I think is quite new, but it uses a lot of technologies that you should be familiar with. We're going to run through it all, things like IIS, branch cache on the client side. But we're going to look at why you should even be thinking about this for a start. But then, to avoid going too technical like we did yesterday, we're going to do a couple of primers on the technologies involved and how we use them. We're going to look at what you can cache, what you should cache, what you can't. And we're going to show you how to do it. We've set up a cloud service as an example, which hopefully is still working. It was last night. And then we're going to give you some options as to how you might want to do it if you want to go and have a play, or if you eventually want to implement something like this. You can do it very cheaply. You can get a pretty kick-ass caching solution just using off-the-shelf technologies. So we're going to give you some options depending on the topology and the location of your users, etc. So why would we want to do this? Why are we here? Why are we even here?
Because the internet is slow.
Not in Scandinavia. Surely everyone has a gig to their desktop.
Yeah.
Yeah, I mean, users traditionally, as we all know, they expect stuff to just happen, like yesterday. Everything to be responsive, all their data to be exactly where they want it. They don't really care where their stuff comes from, they just want it at their desktop. But they do care if it's slow, and that's whether they're browsing, whether they're trying to grab a file from somewhere, whether they're trying to do some work on a document in SharePoint or whatever. That's when the phone starts ringing. The network team, I'm getting a lot of complaints from the users. Is it your fault? And generally, it is. So, as an admin, we want to make sure that everything gets to where it should be as quickly as possible.
Yeah, and even though today the internet pipes are pretty fast, what we'll see is it actually goes under the name Parkinson's law, I think.
Yeah.
Which is that
it is.
the medium will always try to fill the media, and it doesn't really matter what that applies to. The guy that did the study, it was a long time ago. He did the study on, I think it was the British Foreign Ministry for the colonies, and he found that each manager tried to fill his budget and employ more and more people. So he would use his people employing more people just to fill the space and the desk space that they had available to them, until the brink where it was absolutely crammed. Same applies to motorways. You cannot build more highways to get less traffic. Same goes with network. If you get faster pipes, you just get more data. Bigger disk, you just get more disk space. There's no way to just get around that problem. And I don't think we have that slide, but one of our favorite slides is you see the ratio of disk size versus bandwidth. And which one do you think is winning? Do we get more bandwidth or more disk space? More disk space, right? So the Seagate now is shipping, I think, 12 terabyte disks for about $200. That puts it into perspective. Meanwhile, the bandwidth, especially in North America, has been the same for the last couple of years. There hasn't been any change in the amount of speed that they can get out for the price. Yeah, the cost goes down a little bit, but the cost ratio to bandwidth stays the same.
Yeah, and it varies. Obviously, now you've got people connecting from lots of different locations. They're not just going to connect from your, offices necessarily. They could be working from a coffee shop, from home, pretty much anywhere. So things that we might want to cache include Office 365. That's the obvious one. So you might have some on-premise SharePoint, for instance. Config Manager now has Cloud DPs, has for a while, which now works because there's a hotfix out for for branch caching. OneDrive for Business there's a massive demand. Dropbox has a thing called LAN sync, so you can share stuff via Dropbox, and that's missing from OneDrive for Business at the moment. Exchange Outlook address book sync, even in large organizations, the Outlook address book can be huge. So every time you do a sync, obviously, everyone's syncing the same data. Really.
Yeah, and it never does a delta. It always does a full sync.
Yeah.
So if you have a gig, which one customer had, their address book was a gig, and every day, every client that was running Outlook was doing a full sync of a gig. You can imagine if you have a couple of thousand of those machines, there's a lot of data going around. That's basically the same data every day.
So this is just a rubbish diagram that I did a couple of days ago, very late. But that's like that's the good old days almost. Because although bandwidth wasn't fantastic, at least we knew where everybody was. And we had some offices that we didn't really care about. They always used to complain, but quite often there'd only be like 5 people there, so we didn't mind. If you were lucky, you had a nice pipe to head office. All your servers were in the data center. You had a firewall and an internet that we didn't really care about. So few people were, ordering flowers for their wife, but nobody was doing really much browsing. Obviously, the picture is a little bit different now. As we've said, you have many, many types of connections. But what you notice from that is the data center isn't there. Obviously, we're not quite there yet. We haven't gone completely cloud crazy. But, people are embracing the cloud in varying degrees. So you might have some cloud services, but this can apply as much to on-premise services because it's about getting content to the user at the end of the day, whether it comes from the cloud or from your little server in the head office. The point is you want to get data to users, and then you want to cache it and share it out efficiently. Another side to the problem is that you kind of lose a little bit of control. When you embrace cloud services, they own a portion of your IT. And therefore you have less control over how your data gets delivered and where it gets delivered to. And even if you're lucky enough to have a service like a CDN, like a lot of big companies buy the services of a CDN, or you might have a riverbed box even. Quite often, that sits at the edge of your network. So you still have to deliver, even if it gets cached there, you still have to then deliver that to your users, and you might have multiple offices.
So for people that don't know, CDN stands for Content Distribution Network, and it's typically a device or boxes that doesn't have any CPU power, so they can't do any calculations for you. It's typically NAS kind of direct attached storage that sits onto the network. So Akamai and other companies, they own these data centers, and they go to basically the internet providers. They buy a few racks and they put in these boxes of dumb storage that they basically every day ship content to, and by DNS pointers they point. So when you go to Google or whatever to get the little Google image, you don't go to the Google headquarters in California, you go to your Stockholm data center or whatever, or Oslo data center, to get that little picture from your own internet provider. You don't actually leave your internet provider. The problem is, of course, there's no calculation. It's just a dumb pointer to say, get the file from there instead.
Oh, I was going to change that slide. Sorry about that. I made this slide when I was a bit grumpy the other night, so Hey ho. So who here has used BranchCache, is aware of BranchCache, understands what it does conceptually?
Few hands.
Very few hands, but yeah, people might be
Who
aware
in here
of it.
has a
So
Windows computer? Yeah.
who's using Enterprise? Yeah, quite a lot
If
of
you-
Enterprise.
Every single one of your computers that you have has BranchCache
Yeah,
on it.
except for home. So BranchCache is a WAN accelerator. Everyone that knows about it even thinks of it as a peer-to-peer technology, which it has an element of, but it exists to accelerate the transfer of data across the WAN. And it's on every Windows SKU that you
Yep.
have. It's on Pro, it's on Enterprise. The difference between Pro and Enterprise is that on Enterprise you get the native integration with Internet Explorer. So when you're browsing, you can branch cache stuff. You don't get that on Pro. And Pro, you only get integration via bits, so it only branch caches bits downloads.
Yeah, bits is typically content that's distributed by your admin, so patches, operating system upgrades, etc., etc.
Yeah,
But
I mean,
not your user ordering flowers from, you know.
bits is everywhere. I mean, it sits in the background. It does stuff. It takes care of Windows updates. It takes care of Office, for instance, Office 2016, 365 Pro Plus. Click to run updates creates a bits job for every file. So bits jobs always running on your computer, and you can branch cache all of that. And to put it in perspective, if you have a subnet with 200 computers, and today we've got fairly big hard drives, and if you allocate a 10 gig cache to branch cache, then on that subnet you've got 2 terabytes of storage that you can use to share content. So why wouldn't you? It's free. You already own the technology, so you might as well make use of it.
Yeah.
It's a bit of a black box. That's the problem that people have conceptually understanding it. It's that it's not very easy to visualize what's going on. So a lot of people set it up in the lab and don't get it working and just forget about it. But it's worth bearing with and having a go.
And a lot
The
of
branch cache side of things in this is not really. I mean, once it's set up, you just forget about it.
Yeah.
This is more focused on the actual server side of things. So.
Yeah, typically what Microsoft did with the Windows 7, where they pushed branch cache, was they talked a lot about the content for enterprise customers to speed up their network. But that kind of got forgotten a little bit, and now when you read about it, it's more from an IT admin perspective to make big payloads like Windows 10 updates out the door in a more efficient way. But what we're going to cover is more on the end user side to make their experience of things like Office 365 collaboration much better.
So yeah, do you want to run through a quick primer, really, just so that you understand the technologies that we're going to be working with? It's worth knowing a little bit more about.
So branch cache, it's a service that sits on your machine. It communicates with the server side, and the server side calculates a little fingerprint or a content identifier, has many names, or a hash of the file that you're trying to get, whether that's a little bitmap, or a screen, or whatever big file. It sends the tiny percentage of that down to your machine, and your machine then talks to other machines and its own cache to figure out, does anyone else have this data? And if it does, it gets it from there instead of the server. So it's a fairly simple concept. It has an advanced feature in it, which is called a deduplication, which means on a block level, it sees if does this data exist in any other files that I've already downloaded. So for instance, if you update your corporate logo by adding a little, flower on the top, it'll see that most of the bitmaps the same, but just added a little flower bit up top and just basically download that little change.
So anyone using dedupe in Server 2012? Yeah. It works really well, and branch cache from Windows 8 onwards. There's 2 versions of branch cache. Version 1's in Windows 7, version 2 is in 8, 10 and beyond. Deduplication exists in branch cache from 8 onwards. So what it does on the server side, it doesn't need to calculate the hash anymore. If you enable deduplication on a volume, it uses the dedup chunk store, so it makes it even more efficient and really fast. So you can get...
Wrong button.
Thank you. So this is a solution to the problem that we put together. We've mentioned branch cache. It's going to accelerate the WAN, share stuff locally in this distributed cache between all of your users. We're going to connect that up to the cloudy bits. We need to decide what we want to cache and what we want to make the best use of. And the end result is that if you think of it like a CDN, like Andreas explained earlier what a CDN is, it's basically a content delivery network that you can put anywhere in your network. So it's quite a simple concept, I think, really. We're going to take some data from over there, we're going to cache it here, and then we're going to share it out. In reality, there's quite a few steps to that. So what we need to do is, first we need to analyze the data, because the way that we're doing this means that we need to know the specific host names and URLs for that cloud service or internal content or whatever. So you need to do a bit of analysis first. Then we create a cloud service that is going to implement a man-in-the-middle attack, effectively, but a friendly version. So we're going to use certificates.
Yeah, because doing a caching in the CDN type delivery, it's pretty easy when it's not protected media. So just a simple HTTP URL, it's easy to redirect that to another source. It gets slightly more complicated when the data is protected by username, password, certificate kind of HTTPS locations.
Yeah.
So that is what we're going to cover today, is a protected URL on your corporate SharePoint site that you want to access, but you want to share that, or you want to basically accelerate that content and store it locally securely. So you have to intercept that HTTPS connection.
So here's a really stunning diagram that I also did the other night when I was a bit tired.
So this is the corporate diagram, isn't it?
Yeah,
of our corporate network?
That's right.
Yep.
Yeah. This is 2-pint CorpNet. And that's how it is for most people. You have Office 365, then you have yourself, and you have HTTPS. Everything's pretty much HTTPS these days. And so you have a certificate, secure tunnel, and it all works fine. But what we're going to do is we're going to break that in the middle. We're going to put the BranchCache Clouderator service that we named it in the middle, and that's going to break that tunnel, and it's going to create a new one using certificates that we created. So we create a certificate authority that we then trust, and then you need to put that certificate onto your users' machines. So that creates a new secure tunnel between your service and the users. And then at the bottom, obviously, we're doing the branch cache bits to share it all.
So is the audience with us so far? What we're trying to do? Yeah?
Is that okay?
Good.
Fairly straightforward, really. So just a breakdown of what actually sits in the middle. So we've created a VM in Azure, just a fairly straightforward Windows server. Could just as easily be an on-premise server. It doesn't have to be cloud-based.
No.
And that, in turn, has IIS plus branch cache configured on there. So we've set up IIS, we've set up branch cache to generate the hashes on a certain volume, and there's another piece that we then add on to IIS, which is called ARR, which is Application Routing, Request and Routing.
Request routing.
Request routing, which is a bit of a mouthful, so we call it R.
R.
Which is a caching proxy. It does many, many other things, but we're using it as a caching proxy. R, actually, I find it really difficult to say ARR. It underpins many CDNs. Microsoft use it. It's a really powerful tool. You can set up server farms. You can direct incoming requests by looking at the headers and directing it to a specific server. It does load balancing. You can have primary, secondary caches. It's really powerful.
Every single request that goes to Azure goes through R.
Yeah.
But from Microsoft's side of it. So they parse every single request through their R's.
This is going to get a bit comedy. Anyway, and then as part of that, we have the URL rewrite, which is the other component that we use, and we use it in a really dumb way because all we do is we say, okay, I've got an incoming request to this host name, actually forward it to the host, and then we'll get the response back and put it in the cache. Fairly straightforward, right? So we're not doing anything fancy. We're using this in probably its most basic form.
Yeah. But of course, the smartness is then comes the second request coming in. We already have the content. The server still goes to the original content to see, has it changed? But if it hasn't changed, it redirects the client to its own local content. And then by using branch cache, we then say, you shouldn't actually get the whole file from the big cache. You could use ARR to just do content caching without branch cache, and then you would just have a local cache, kind of like a squid proxy or any other kind of proxy. But we'll reply with the branch cache data, so the client will be extending it out to do a local search.
So should we have a little look? See
Yes.
what it looks like? Yeah,
Yep.
let's actually see some stuff, I think.
Yeah.
Enough slides for now. So, if I start with, this is just our Azure. We've got some resource groups. We can see here we've got the branch cache is set up as a cloud service. So we've got a virtual machine called BranchCache somewhere in there. And come on. Yeah, and you basically create an HTTP endpoint, which is this, which is the cloud service itself, which gives you an IP address, which is the important bit, because that's the bit that you have to put into your DNS. For any URLs that you want to cache, you point them at this endpoint, effectively. So it's fairly straightforward. It's just a Windows Server 2012 machine with an HTTP endpoint, and I've got a little...
So basically, are you going to show the DNS config? No?
No, because
I'll just mention how. So when the client is on your corporate network, they go to, they want to go to the 2pint.office365.com or whatever. The DNS sees that request, and instead of responding with the regular proper IP, it says, well, I know that this URL should be cached, and it will ship us over to this IP instead. So the 40 dot whatever. So we're taking the request and redirecting it to us.
for the purposes of the demo, and if you want to play with this and set it up in your lab, obviously you can just use your host file. So on my machine, I've just edited the host file. There's certain URLs redirected to that IP address. So this is in IS Manager here, which is fairly familiar to some of you, I'm sure. We've got R. And this is the cache. It gives you a quick overview of what's going on. So we can see we've got a nearly 40% hit ratio. So I fired this up about an hour ago and was browsing URLs to warm up the cache. We have over on the right hand side, you have a cache warm up option. So you can set it to go to a URL like 2pintsoftware@sharepoint.com, and you can say grab everything from there and put it in the cache. So you can pre-warm up the cache before you start, which gives you a head start, obviously. If you don't do that, then it still works. Every time someone requests something, it gets put in the cache.
Yep. Because of course, if you cached every single content that your users request, the cache could become enormously large.
Yeah, it kind of defeats the object of what we're trying to do. We're trying to be lightweight and only cache and only transfer the stuff that the users want. So you have to be careful. Look at your cache size and what you want to put in there.
Yep.
Let's have a look at the site itself. The default website doesn't even have a default start page or anything. The only thing that we do configure on here is the URL rewrite component of R, and this is a single rule, which is the inbound proxy. And who has worked with regular expressions or understands what they are? Yeah. So it uses regular expressions to evaluate an incoming request. And then we set up some rules. So the first rule basically says grab everything, and
Yeah, so basically the rule set that you can create is, I know these files are typically very small and there's no point caching them because it's going to take longer time to do the whole branch cache thing. But these types of file are typically larger, and that's the ones that we want to do. So maybe not do your tiny PNG files, your CSS files, or typical files that SharePoint's using, like your .js, your JavaScripts, etc., etc. Don't cache them, but cache your Word documents, your PowerPoints, your Excels, etc., etc.
If this looks a bit daunting, don't worry. There's some really great examples on the Microsoft website of how to create rules and how the syntax works. What this example does is to look at the host name of the incoming request, and it tries to pattern match. In this example, we've got SharePoint and Office, so anything with that in, and it lets you test that. So if I say 2-pint software dot,
and it's blazingly fast.
SharePoint
And remember that Microsoft does this on every single request that you do up
.com.
to Azure. So it doesn't have to read anything from disk, etc. It's just in-memory regular expressions. And so it's blazingly fast, and it does it for every single request that you do.
So I did a little test on the 2-pint Office 365 default URL, and it says, yeah, it matches the pattern. And then you get a little back reference there, which is C2, which is important in when you're doing request rerouting. C2 is a back reference, and it uses back references in helping to create the URL that you return, basically. So you can use it for things. A lot of people use it for shortening complicated URLs. You say, if the URL contains this, return this one.
Yeah.
So it's quite powerful, but we're using it in a really simple
Yeah,
way.
who's done like on the OneDrive, click the little short, give me a short link? Yeah, that's using R. That creates an object in R, ARR, to create that for you. So they basically store the long URL and give you a short URL, and it goes to ARR for the parsing.
So,
Simple.
yeah, so our rewritten URL is basically the original one that came in. It just looks at it and see if it's HTTP or HTTPS and forwards it on to the target URL. So what else do we do on IIS? The other important thing that we do is on the certificate side of things. It's getting a bit slow. Okay, so when I mentioned earlier you need to do some analysis of your URLs, what I did, and what I can't show you because it messes up the certificates on the machine, is you can use a tool called Fiddler. Who's used Fiddler before? It's great for looking at HTTP traffic. It's really cool. Free tool. You install it.
And it's great for messing up all of your certificates too.
It is, yeah. It's great for wasting 2 days of your time because you didn't know what it had done in the background. But leaving that little story aside, you can get it to examine HTTPS traffic. So you can fire it up, browse to your target content that you want to cache, and it gives you a list of all of the requests and responses. So you can say, oh, okay, that's my URL that I need to create a certificate for. Because you need to create a server certificate for every host name. Although, what you can do, what I haven't done here, but what I've discovered since that you can do, is that you can use wildcards. So although here I've got 2-PintSoftware-my SharePoint.com and 2-PintSoftware.SharePoint.com, I could, in theory, create a certificate with star.SharePoint.com.
Yeah. Who in here doesn't understand, or maybe that's nobody wants to admit it. Basically, I'll back it up a little bit. So basically, what we're trying to do is we'll have these HTTPS requests. It's secure. It's signed from both sides, and we're gonna try to break it because we need to look what's in the request. When something is HTTPS, there's no way for us to figure out anything except the IP of the machine that the request is going to go to. We don't even know what the URL is because the URL is encrypted. So we need to decrypt that, and that's kind of too expensive to do. Only the NSA will do that for you on a real-time basis. So what we want to do, we're going to fool the client to use another certificate that we already have and use that instead of the other certificate of the source. Because then we can decrypt fast because we know the certificate, look at the URL, and then basically rewrite the URL but still maintaining an HTTPS connection.
So here, it gives you the choice of the certificate that you want to create, and I've created a certificate for these three at the bottom here, the ones that I found in my Fiddler analysis. And then you bind that to a host name, which means that every time a request comes in for that host name, it's bound to that certificate. So that's a certificate that the client trusts, because we create a self-signed certificate, a root certificate a certificate authority, I should say, that we trust. And then you can put that on your clients. You can use GPO to do that. But as long as the client trusts that certificate authority, then you're good to go. So far, so good. What else do we do on the server side, Andreas? What else do we need to show? We need to make the certificates, obviously. So, anybody used make Cert before?
Yeah. What couple
Damn
of
it,
hands?
somebody knows what they're talking about.
I know.
I can't.
So basically, in a typical, when you put this into production, you would use proper certificates and whatever. But if you want to play with them in the lab, you can create your own certificates, because you probably have, a little lab that you play with. So then you use the make Cert.
This machine's really slow, actually, but the connection's getting slow. So I won't show you how to do the make Cert. I will show you the batch file, because obviously you want to automate this. You want to be typing this. This is a command line.
So it's basically something that you don't want to do.
That is a single command line.
Free typing up, but all of this is documented in some of the blogs.
Yeah, you have to hunt around. I found a really great article on Stack Overflow or somewhere by a guy that we used to work with called Roger Lipscomb, who's an amazing developer. And he was quite a guiding light in this. But effectively what we're doing with the first command line here is this is where we're creating the certificate authority. And then in the subsequent command lines here, we're creating each of the server certificates based on that authority. So each of those server certificates are based on the certificate authority that we create in the first step. Fairly straightforward, really. Once you've done the first bit, you can just copy and paste and replace the URLs in there.
Yeah. So basically, you get a certificate, then you put that on the client, and the server side knows about it as well. So when the client comes in and it's get redirected, we basically say, use this certificate instead of the Microsoft certificate. And the client's going to say, okay, because I trust you. And then we'll go to the R server.
Mm-hmm.
And that will then look at the request, and if it has already cached it, it will give you the branch cache fingerprint, or the hash, basically, back to the client, who will then look in its own cache and then talk to other machines to see if anyone else has it.
So the command that I just ran here was netch branch cache show status all, which gives you a rundown of what's in the branch cache caches. Branch cache has two caches. Publication cache contains the hashes, and the republication cache contains the content. On the server, obviously, there's only hashes because it doesn't store the content. And you can see that in the publication cache here, we've got half a meg.
Half a meg. Yeah. So if you take the size, how branch cache works with the size ratio, the hashes are about 1 to 2,000 of the data that you've actually downloaded. So half a meg corresponds to about 500 megabyte, or up to a gig of content, which is quite a lot.
The other point is that as well as accelerating by using branch cache, we can compress stuff as it comes through R. So we enable dynamic content compression. So as well as having static compression, which is kind of enabled by default, I think, we can enable dynamic content compression, and with certain files, you get a really good compression ratio. Yeah. So that's another. You're shrinking the footprint yet again. So it's all easy stuff.
Yeah, you can a typical JavaScript that could be about 100K in uncompressed format. You can easily get that down to a couple of K. So it's a great, and if you take that JavaScript many times, that saves you a lot of bandwidth. So what does it look from the client perspective? From a browser?
Let's have a look. From a browser,
It's very
it looks
exciting, isn't it? You don't see anything.
No.
It just looks like a browser.
Okay, so this is my local branch cache, which you can see current cache size. Again, we're on the client, it's the reverse. So we're looking at the local cache, not the publication cache, because we don't store hashes because we're not a branch cache server. So hash.
So why is it empty?
It's empty because I haven't cached anything yet. I just
Because you cleaned it out.
I cleaned it out. I did a flush. Branch cache, branch cache flush.
So this is what it looks like.
This is what it looks like. This is the 2-pint Office 365.
And I think if you go up here, you'll be able to see. This is where you typically would see the Microsoft certificate information. But here you'll be able to see that this is HTTPS connection is actually secured by the 2-pint certificate.
Yeah. So you can see here in the certificate store, there it is, 2PS root authority, along with all of the other big ones.
So some people say that this is a bit dodgy and you shouldn't be able to do this really. And in some sites, typically the ones that do payment card transfers, that's signed by a EV signing certificate, the ones where you get the proper green bar. Do people know what I'm talking about? I think there's a few out there that you.
Yeah. All of the big names.
Yeah.
Yeah.
The problems with the EV certificates are they are not wildcard certs. You cannot do wildcard certs. You can only do multiple host names in those certs, and which is a bit of a bummer because it's kind of hard to do. You could still do what we're doing, but you lose the green stuff. So we probably don't recommend you to do caching on those types of sites. But typically, you wouldn't be interested in cache everything on the content, on the internet, because that would be, you would run out of disk space pretty fast. So you'd probably want to do your own internal corporate information in Office 365, and none of that uses any of the green EV signing certs anyway, or not. It's not signing certs; it's SSL certs.
Yeah. Okay, so I'm going to go to my OneDrive.
Ooh.
I'm going to try and cache something from the OneDrive. So what we've got here is the URL. You notice the URL is the 2pintsoftware-my.sharepoint.com, which is one of the host names that we created a certificate for. So if I, for instance, download this little zip file, and we save it. Okay, let's see if we got anything in the cache.
So
now you can see
we got data in the cache.
Thank you to the demo gods. We have some data in the cache because the file that I just downloaded from OneDrive is now in the cache. So if in the 2-pint headquarters this guy wants to download the same file, he's going to get it from my cache. So I've saved a mighty 2 meg already. So you can see with all of the traffic, I mean, even if you get 200 users that just go to the SharePoint homepage, you're going to save a ton of bandwidth. And it just works in the background. So
there is a latency aspect to it. So depending on what content you want to cache, for instance, if the file is a tiny, like a couple of Ks large, you typically don't want to cache that because the request is going to go through the R. It's going to give you the branch cache data, the little fingerprint. Then your branch cache is going to go, hey, I don't have the file, I'm going to go out to the network and ask if anyone else has the file. And then if nobody responds, now we're kind of up to building up milliseconds, maybe up to a second or two. Then we're going to go and get the real file. So that's not so bad for a single file. But if you have thousands of files for a typical web page, or even a million, if you have an enormous big web farm, you don't want to cache every kind of little file. So there are thresholds that you can set to files smaller than this size. Don't care about them. Just get them because it's going to be faster than caching it. But your typical PowerPoint, your Word documents, the much bigger files, that's what you want to cache.
Yeah. So I'm just going to download this again. And there you go, it completed. It took like 5 seconds the first time, but it's completed really quickly because obviously if I want to download it again, it's just going to get it from my local cache. So, pretty efficient. Okay, let's see where we are with the slides. So, we've pretty much explained this, I think. Just to recap, you need that trusted root authority, off of which you create a server-side certificate for each host name, having done the analysis, and then the trusted root certificate then goes into the user portion of the certificate store. It's important to get the differentiation. On the server side, you install it in the local machine store. On the user side, you install it in the user store. This is just a little recap of the command line for make cert. This is just creating one host name certificate.
And if you are using and building your own certificates, make them secure. Don't do what Dell, Lenovo, and some of the other hardware manufacturers have done, which is basically put a local certificate, which means that they can break any HTTPS connections, and put the private key on the same machine or leak it, because it means that that certificate could be used to hijack any HTTPS connection going anywhere. Does it make sense? Yeah, keep it secure. I mean, I don't understand how they managed to do that, but
who knows?
It's pretty bad from a security perspective.
This is just really to highlight how simple it is. I showed you the GUI version of the URL rewrite, and all that does really is writes to web.config, which is at the root of every IIS website. So you can just edit this file if you want to directly. You can copy and paste this, create a web.config, and off you go.
Yep.
So it's fairly straightforward. You can see we've got the compression enabled in there, we've got the rewrite URL, so it's all good to go. It's the GUI version, we've seen that. So final checks. This is just a checklist really. Branch cache, hash cache minimum size, we mentioned it's a registry edit on the server. By default it's 64, change that to 4, whatever you want. Because in SharePoint, for example, you've got lots of image files which are quite small, but there's a lot of them. So obviously every little bullet and icon and such in SharePoint, because it's quite visual kind of experience, you get tons of images that need to be downloaded every time you visit that page. For the first time, obviously, you're going to need to download those.
I mean, if you're looking to actually do this, I would do a little bit of background checking. Look at your SharePoint, for instance. See what kind of files are they typically downloading. Look at the logs of your Exchange servers to see which attachments do people typically download. Just because you have your brand new CEO sends out his global corporate yada yada vision
video that he made,
which is about like 100 meg, and he attaches it to the email and sends it to everybody. Doesn't mean that people will look at it, but it's quite likely that they will. So look at what data are you typically requesting a lot, which data, and you can probably get your network team to help you there to say which URLs are we getting a lot of traffic from, to see what you can shave off.
I'm just going to show you something. If you do have a go with this, there's quite a good troubleshooting tool within IIS called failed request tracing, which you can set up what you want to trace, just set it to trace everything basically, but then you can view the trace logs, which I think I've got open here, and it creates a bunch of XML files for each request, and within here you get quite a very detailed flow of the request as it comes in. So we can see endpoint information, we see the request headers, what it was trying to download, and then we can see the notify module, the set request header, authentication. So you can trace, and if there's something that's gone wrong, there'll be a warning box on the right hand side, and it'll kind of highlight where you've gone wrong. It's great if you're messing with the rules, because it can tell you. Here you can see the certificate authority. It can tell you where your rule's going wrong, effectively.
Yeah.
So it's just a great tool for doing that. And at the end, it can tell you.
So I think a lot of this.
That's what gets returned. In the
A lot of
response
this
header.
is going to come your way from Microsoft, we think. Microsoft did a lot of great work in Windows Server to make storage into much more of an easier way of dealing. So they basically went head-to-head against the big storage companies to do their own storage solution. The number one issue that they're having now with the Windows 10 deployments is size. The size of and the amount of data that they have to push with the current branch updates every single month or quarterly or however often you want to push it is the number one concern that people have raised with Microsoft. We're pushing too much data in the networks. And how can we make this a better story? And because not all companies have great systems like Configuration Manager, etc., to do this on a scheduled basis. If you have your own WSS server or even going over the internet by your own clients, just getting it, every single machine getting 3.5 gig of data is going to be a lot of data.
True. So if you want to scale this out, I'll quickly cover how you might want to do it in a cloud-based scenario. You might want to scale it because you're going to do this on a big scale. You're going to have a massive cache. You're going to have tons of content. So we could make some more servers, or we could be a little bit more intelligent and use scaling. So because within Azure it supports cloning, we can take that BranchCache VM that we made and we can clone it. And a good byproduct of the cloning is that you get the same server secret for BranchCache. Now, the server secret in BranchCache is used to create the hashes. And cut a long story short, if you have multiple BranchCache servers, say within a cluster that we're going to create here, or within an R farm, you need to have the same server secret for each BranchCache server, so that the hash is the same that's returned each time. So that's a nice byproduct. So you need to clone the VMs, and then really the only thing you need to do post that is to install the server certificates to make sure that's all in place. And then you can configure the R cache. You can have a primary cache on each machine using a fast local disk. Then you can create some Azure storage, use Azure files, and use that as a secondary cache. So if you really want to scale this, then it's possible on a massive scale. And then you're looking at basically, you created a CDN, just like the big boys. But we don't want, if we create 4 VMs, we don't want them all running all the time, just in case it gets busy. So with scaling, obviously, you can have them fired up based on certain conditions. And because it's quite a CPU-intensive process, both of the BranchCache side of things and the certificate processing is quite CPU-intensive. So you can check CPU usage. So if you start with your BranchCache 1, if CPU goes above 75%, fire up BranchCache 2, and so on. And then if it drops down below 50%, bring them down. So that's pretty efficient use of your Azure time. So how would we implement this? I mean, we've done it very simply. We've got a cloud service, and we've got one location. That's fine. But you might have multiple locations. You might have multiple services that you want to cache. You might have a portion of Office 365 in the cloud. You might have some in-house SharePoint somewhere that everyone needs to get to. So you can create a combination of the cloud service that we've just showed you, or you can just have a VM somewhere running that you can create this on locally. Use dedupe. We mentioned dedupe earlier. Use dedupe on the volume that you're going to put your R cache on, because then you've got the Holy Trinity. You've got the branch cache, you've got the compression, and you've got deduplication. So you're really doing the best you possibly can to minimize the amount of stuff that gets to your users. The other key point is to try to put the cache as close to your users as possible. So you could have a scenario where you kind of have a master service, then you have a downstream R implementation locally So you get the best of both worlds. You're moving the cache. Having the cache in the cloud obviously might not be the best solution because your users might be getting to that from so many different locations worldwide. You might want to spread them out.
For instance, a
On-premise.
lot of the time, sometimes larger companies, they're forced to use data centers across the globe because whatever X reason. So if we're here in Scandinavia, we're forced to go to Asia and some part of, maybe say the data centers in Malaysia, just the latency of that transaction going all the way to Malaysia, if we cache that locally instead, we'll save an enormous amount of frustration from the users from requesting that data across the globe.
And as I mentioned briefly earlier, you can use the cache warm-up. So you can set that to run in the middle of the night. You can get your content from the other side of the world, bring it closer to your users, put it into your R cache, and then it's there when they need it. Use cheap CPU for the grunt work, obviously. If you've got servers lying around that you could put this service on, then put it on there. It doesn't need to be anything fancy, really. You just need some CPU. Consider Azure Stack. Well, yeah, why not?
Yep.
Maybe at some point in the future. At the moment, you can run it perfectly well on Windows Server 2012. But if you want to recreate the whole cloud experience and the scalability aspect and all of the elastic scalability, then you could, in theory, should be able to use Azure Stack when that comes along.
And the nice thing is that the user will never really see anything. They just see the amazing speed increase when they're accessing your resources on the network and say, hey, this network is really fast. And they'll start saying, no, I'd like to go into the corporate office because the internet and the stuff is much faster there than it is at home.
I was going to work from home today, but bloody internet's so slow, I'm going to go into the office anyway. And then everyone's unhappy, wife's unhappy, kids don't see you. So the outcome of this should be that...
And what's the solution to that? You have another R solution that you put in the cloud. Because if you can run this entirely like we did in Azure, it doesn't matter where you are. You just have to redirect the request coming from home. You could use either by doing your DNS, so your machines at home is using your publicly available company DNS to do the relocation, or you have a host file or any other solution.
Yeah, many ways. But ultimately, the reason we exist is to make the users' lives better and to make their experience as positive as possible. So the way that we're contributing to that with this solution is that you get much faster browsing and file serving their data.
Who thinks that Office 365 SharePoint is fast? Yeah.
It's like that. It's like
if you put it on this solution, it gets much, much better, and the experience is much, much faster.
Yeah.
It's pretty much day and night, I would say. I don't know, yeah.
And the network guys will be your friend, which is a kind of a unique experience.
Yep.
And it's cheap. All of the stuff's out-of-the-box technology. BranchCache we already own.
Yep.
R itself is just something that you can install for free using the web platform installer on top of IIS.
Yep.
So it's all there, really. It's there for you to go and make use of. So to finish up, we've got plenty of time for a few questions. Just a couple of name checks, because there's a company in Australia that we're kind of looking at the same thing, and they've got a great blog series on that. And we spoke to them about how this all works. So it's worth checking. If you're interested, they've got a great blog series on how their solution evolved.
Yep.
Roger, it's great. Thank you very much for giving us the make cert pointers. And finally, really, that's us. Check us out. Have a look on the website. We've got some blogs and stuff. Got anything else up there?
As I think Phil mentioned in the beginning, so we're building a product solution or a service solution that you could just sign up on these technologies. So we're running it ourselves to showcase it, and we're very pleased with the performance that we see out of it.
We have a product called Stifler.
Yep.
That takes care of on-premise kind of bandwidth management.
Yeah, it takes care of all the bits jobs that you do. So all of the typical big Windows updates, patches, the data that comes in Configuration Manager, and make sure that all location just uses a tiny bit of, or the bandwidth that you're assigned to that location. But Stifler's mom, which is this solution, is basically taking care of all the collaboration and everything that the user does in there. So we have a big customer in the US who's looking to put all of their data into Office 365. So basically everything that they do. So it's about 300,000 machines that they're going to put into. And that typically would go through 2 data center pipes. And it doesn't matter how fast their internet pipes are in that location, they will fill them if every single user on the Monday morning open up that PowerPoint that their CEO sent out. Because every client will get it. So they're looking for this solution as well. So.
Okay, thank you very much for listening. Thanks for coming along. And any questions, fire away. Yeah. Oh, good point. Yeah, with BranchCache, we're using distributed cache.
So the question was,
Yeah,
are
the
we
question
using
was,
distributed cache or local cache on the client to access the data? So
Yeah.
So the question was, are we using hosted cache,
Or
distributed
distributed
cache, or local cache,
local cache
with the data?
Yeah, we're using distributed cache on the client side. If we wanted to use hosted cache, then that would need another server, which kind of defeats the object a little bit of what we're trying to do. So distributed cache is the way to go in this solution, because unless you had a huge site and you didn't want to put I'm thinking if you had a huge site, then if you needed a hosted cache server, then you might as well put R on it anyway.
Yeah. So BranchCache exists in 3 different flavors for the people that don't understand the question. So it's a hosted cache option, which is where you take a server and you say, I want this server to cache all the files for these machines. Then you have distributed, where every single machine stores the data, but they all talk peer-to-peer kind of between them. Then you have the third option, which is local only, where it's only looking in its own cache. Obviously, there are different consequences and benefits with the different options. Local is the fastest because it doesn't have to go out anywhere on the network. It just looks in its own cache. So that's by far the fastest and best if you're caching lots of millions of small files, because it doesn't have to go out on the network for each request, which is what creates the long timings and the latency. Meanwhile, if you have a large amount of different files, distributed is probably best, because you use every single disk of your machines that you have within that location. Hosted, we never really see any use of, because it requires a server put in a location that's close with good bandwidth for that location.
There's no reason why it wouldn't work with hosted cache mode, because BranchCache is BranchCache. It's kind of outside really of the solution.
No, it should work just fine.
It would work just fine with hosted cache if you were already using that.
The limitation on the distributed cache earlier, I remember, was that it just works on the same subnet.
Yes, that's
so
correct.
the question was, if there's a limitation with the distributed cache only working in the local subnet. It's both true and not true. It's using a multicast forwarding to request the content. As long as that one goes across your multiple subnets and the other machine can then respond back, it works across multiple subnets. So it's not a subnet broadcast, it's a multicast broadcast. So if your network infrastructure, this goes back to the network team, once you set this up, they will probably see lower than bandwidth. You might want to go and talk to them and say, hey, we have this multicasting, and they're going to say, ooh.
Yeah, having become their friends, go and talk to them about multicasting, and then they'll instantly not become your friends again.
Yeah. So do it in that order. Save bandwidth. They'll be happy. Then you can talk to them about multicast, and maybe getting it even better. They might listen. If you go first and say, we got this multicast thing, they're going to say, nope. We've done a lot of work. A previous product that we worked with used multicast as an option to distribute data. We've been in a lot of meetings where you say multicast, okay, let's talk to the network team. Network team brings in security team. They say, no.
That's what they say.
Yeah, that's what they say. And then you'll have meetings and meetings, and the answer is going to be, well, no. But it's technically possible.
Yeah.
We would never recommend it to do it from a people and process perspective, but from a technical perspective, it's no problem.
When the overhead obviously is, if it's subnet based, then if you have one download per subnet, so you need to decide if that's acceptable, basically.
And typically these days, more people. I think it's a bigger issue for the payment card industry, because for the PCI, which is the payment card industry standard of how your point of sales and stuff should be able to talk to each other, they typically put the point of sale system on a different subnet to the admin stations that you might have in a store. There you might have a 50-50, like 50%, like 5 payment stalls or kiosks or whatever, and 5 admin machines, and you want to share that content across. But then you might be worth doing it, the multicast stuff.
Okay, any more questions? Good. Thanks very much for coming along.
Thank you.
Have a good day and have a good weekend.